So hello everyone, I Raghvendra Singh. Welcomes you all in this channel. So today we are going to discuss linear algebra. So right now we will discuss about orthogonal matrix. So one more thing, that we all are aware of matrix, right? Matrix. What are the matrix? Something written in this bracket: 2 1 3 1 2 7 2 1 3. So we say this is 3 by 3 matrix. Why 3 by 3? This denotes to row and this denotes to column. Okay, so these are columns, these are columns, these are columns, these are rows, rows and rows. Okay, so you all are aware of matrix because we have studied in 12th class, also in IIT JEE syllabus. So just now, what does it mean by orthogonal? Orthogonal means like 90 degree. Ortho means 90 degree. It sounds something like this, no? So basically just leave this. So I'm just trying to say that A dot A transpose is equal to I. What is I? Identity matrix. Identity matrix. Okay, I is identity matrix. What is identity matrix? If we are taking sorry, identity matrix of 3 by 3 order, then 1 0 0 0 1 0 0 0 1, the 3 by 3 identity matrix. Okay, so this is identity matrix. So basically this A and this A transpose. Now we all know that how to take transpose. Suppose we have matrix A. Suppose we have just taken here example. Suppose this was equal to A. Then what will be the transpose of this? Okay, so basically nothing need to do. Just if we have given these numbers, then convert this is row, convert in column, this is row, convert in column, this is row, convert in column, and nothing else. Or you want to see this, then this is column, convert in row. Suppose 2 1 3 is in row, so I can write it 2 1 3 in column. So 1 2 7 is in row, so 1 2 7 is in column right now. 2 1 3 2 1 3. So this is called the transpose. Means we have write from row to column. This is column and this is row and this is column. Okay, so I hope you have understood that what is transpose, how can we convert any matrix in transpose. Okay, so now let's take one question and we will prove that it is orthogonal or not. So question is, prove that the following matrix following matrix is orthogonal and hence is orthogonal. And hence find A inverse. So suppose we have given matrix minus 2 1 2 2 2 1 1 minus 2 2. So this is matrix A which we have given. One more thing, that is 1 by 3 is outside. Okay, yeah, sorry, I didn't write that before. So this is 3 by 3 matrix which is given. So we all know that here it is saying it is orthogonal. We have to prove it and we have to find the A inverse. First of all, we know what is condition for orthogonality. A dot A transpose is equal to I. This is identity matrix. So this is A, and how can we convert it in transpose? Simply, this is in row, we will convert in column. So -2 1 2. This is column, this is row, we will convert it in column. 2 2 1 1 minus 2 2. So 1 minus 2 2. Okay, so this is our A transpose. And now we have to multiply A dot A transpose. A dot A transpose. If this will form a identity matrix, then we can say this is orthogonal. Okay, so let me do this. I should write or just I need to do direct? Let me write it for simplify. Like this is given A matrix. -2. Okay, so we have just written it. Now how we will multiply it? We all know, because we have done this type of question in our 12th class, also in while preparing of IIT JEE. So basically this row will multiply from this column and add, then second this, and then this. Okay, so yeah, it is something very, like, we need to be very careful here, although we can do mistake here. It was equal to I. So like this is 1 by 3 and this is 1 by 3, so this will be 1 by 9. So I'm just writing it 1 by 9. Okay, so let me multiply. So -2 will multiply by this, so -4. -2 will multiply this, -2 yani +4. 1 2 2s are 4. Then second this one, -4, this and 2 and 2. Then this will multiply from this, -2 plus 4. Same goes with this also. We will take this row, we will multiply from this column, and this column. Sorry. Okay, so let's do this. -4 plus 2 plus 2, this I'm multiplying by this, then this, 4 plus 4 plus 1. Yeah, these here will be sign of plus, that we have to add all of this now. So here will be just nothing. 4 plus 4 and 2 minus 4 plus 2. And now this row from this column, so -2 and again -2 and 4. 2 minus 4 plus 2, 1 plus 4 plus 4. Simply now we have to add it, and 1 by 9 4 plus 5 plus 4 9. Okay, minus 4 2 plus 2 4, minus 4 plus 4 0, minus 4 plus 4 0, minus 4 plus 4 0, 4 plus 4 8 plus 1 9, 2 plus 2 4, minus 4 0, minus 2 plus 4 0, 2 minus 4 2 minus 2 minus 2 plus 2 0, 4 plus 1 5 plus 4 9. So this is here. Now just see this is 1 by 9. 1 by 9, if we will divide each and everything, then we can write this like 9 by 9 1, 0 by 1 by 9 0, 0 by 1 by 9 0, then 0, then 1, then 0, then 0, then 0, then 1. So this is our identity matrix. So hence we can say it is orthogonal matrix. So I hope you have understood. Yeah, one more thing, we have to calculate A inverse. We know the formula of A inverse. It is equal to adjoint of A upon determinant of A. Yeah, so again it is a big process how we calculate adjoint. I will discuss in upcoming questions. Like here adjoint, we will calculate the minor of it. Minor how, like there is 2, so we will hide this and this, then 2 2 is 4, minus 1 plus 2 6. So basically this 6 will be A12, then we write form a matrix again, and then determinant of A, we all know how to calculate determinant. So it is something how we find A inverse. We all have done this in 12th class, so I'll discuss this in next question. Okay, so now let's discuss about eigen values and eigen theorem. So basically Eigen is the name of mathematician. So what he did, basically he just formed a matrix, then he conclude a equation that was, suppose our matrix is given A minus lambda I. Again I have told you what is I. It is identity matrix 1 0 0 0 0 1 0 0 1. Okay, so it is identity matrix. Yeah, so just here's nothing so-called discuss. We will just directly discuss about the question. So basically we will be given a matrix A and we have to calculate it by doing this matriculation. So let's start. find eigenvalues let me just also conclude vectors also. Vector, I'll discuss about that how we can calculate vector. It is also a simple process. Before we have to calculate values, then vector of the following of the matrix. And suppose our matrix is given 8 minus 8 minus 2, 4 minus 3 minus 2, 3 minus 4, 1. So this is a matrix which is given 3 by 3 matrix. Okay, so how can we calculate? I have told you that A minus lambda I. So basically minus lambda I means 1 0 0 0 1 0 0 0 1. Okay, so basically if lambda will multiply from this, then 1 into lambda lambda, 0 into lambda 0, 0 into lambda 0. So basically 1 lambda will be here, here and here. And if we will minus it from this matrix, then 8 minus lambda minus 8 minus 0, again minus 8, that will be same, right? So I'm just writing it 8 minus lambda, and this will be as it is, minus 8 minus 2 4 and minus 3 minus lambda, minus 3 minus lambda, minus 2 minus 0, so minus 2 as it is, 3 minus 4 will be as it is, then 1 minus lambda. Okay, yeah, so we have just done this. Now simply what can we do here? One option which I can see that we can convert in this echelon form. Oh sorry, I didn't discuss about echelon. Basically what we do in echelon, that the triangle, this is now, there was kind of triangle now, this triangle will be 0, well 0 0 0. Basically we have to do here 0, so that this one equation can be formed. So this will be lengthy process. So just there is one short trick to find the value of lambda. This will be cubic equation, so we may face some difficulty to finding out, but what can we do here? We will write firstly lambda cube minus s1 lambda square plus s2 lambda square minus determinant of A is equal to 0. Yeah, so basically we have to take care of this equation in our mind, that here will be minus, this will be plus, and again determinant of A will be minus. So there is kind of equation we need to take care of it. Okay, yeah, so lambda cube. So how can we calculate S1? Now here there is kind of rough work to calculate S1. So basically what we do in S1, that we see the diagonal. Let me do this. diagonal. We added diagonal, like here is 8 minus 3 and minus 2, so we will add it, 8 minus 3 and minus 2, so s1 will be equal to 3, right? This is s1. So sorry, this is 1, no? This is 1. So 1. This is s1. Basically we have 8 minus 3 and plus 1. 8 minus 3 and plus 1. Basically we add it now. We add it diagonally. So 8 plus minus 3 and plus 1. So 8 plus 1 9 minus 3 is 6. Sorry, I'm just which I will say that take care of these signs. We may get confused here. Now the main part starts off s2. This is our s1. So how can we calculate s2? So see this here. For s2, what we do, that we calculate the minus of diagonal. The minus of diagonal, you understand now? Suppose we will calculate along 8, then this 8 we will hide, this we will hide, and this we will hide. We will simply write minus 3, minus 2, minus 4, 1. Okay, yeah, and we do not write 8 because here something like this. So we will write minus 3, minus 2, minus 4, 1, and plus. Now we will move second diagonal, that is minus 3. So in minus 3 we will not include this and this. So here we will be having 8 minus 2 and 3, 1. 8 minus 2 and 3, 1. And now we will move towards 1. So we will add this and this. So 8 minus 8, 4 minus 3. 8 minus 8, 4 minus 3, 4 minus 3. Okay, so we will simply calculate this kind of determinant. This kind of determinant. So basically minus 3, minus 8. Minus 3, we are just solving, and simply this will multiply minus this. So minus 3, minus 3, minus minus plus 8, here again minus 8. Minus 3 and minus plus 8, minus 8, so minus 11 plus 8, minus minus plus 6, 8 plus 6 is 14, plus 8 3 minus 24, minus minus plus 32, 24 plus 32, minus 24 plus 32, 8. So basically the final value will be 19 minus 19 plus 14. 5. H2 will be 5. Okay. So this is 5. Now simply we will put S1 and S2 value here. So one more thing, that is we have to calculate also determinant. So how can we calculate determinant? For determinant, like this is A, determinant of A is equal to, with respect to 8, then 8 minus 3 minus 8 minus 3 minus 8 minus 3 and minus 8 minus 3 and minus 8 minus 11 minus 11 and minus 8. Along we will expand, this will be plus 8 because this is A12, so this here will be sign change, because we all know that this and this sign always changes. So basically this and this we will hide. So 4 minus plus 6, 4 plus 6, 10, and this minus 2 along this and this, minus 16 minus plus 9, minus 16 plus 9, 7, minus 16 plus 9, minus 7, right? So minus 88 plus 80 minus plus 14. Here will be minus 88 plus 80 minus 8 plus 14. So this will be 6 only. Okay. Yeah. So 6. So determinant of value is 6. So we can put here like lambda cube minus S1 value is this. S1 value is this 6. Lambda square plus S2 value is this 5. 5. So this is lambda only. 5 lambda minus 6 is equal to 0. Now we have to solve this cubic equation. Basically what can we do here, like here we can take common, so lambda common, so lambda square minus 6 lambda plus 5 minus 6 is equal to 0. So we can make here factorization like lambda square, so lambda square minus 3 lambda minus 2 lambda So basically we will calculate this equation and we will get the values. Lambda is equal to 1, 3 and 2. So why 3 values? Because we have the cubic equation, that's why we have 3 values. Okay, so now let's calculate vector, eigenvector. How we calculate eigenvector? Basically eigenvector like we have values of lambda is equal to 1, 3 and 2, right? We have the values of 1, 3 and 2. 1, 3 and 2. So firstly we know that we have equation this, but we have this 8 minus lambda minus 3 minus lambda 1 minus lambda. 8 minus lambda minus 3 minus lambda 1 minus lambda. We have equation this, and all are raised is minus 2, 4, 4 minus 2, 3 minus 4. We have given, and we have just written this one only. Then right now let me just, for lambda is equal to 1. So what we will do here is we will put in place of lambda, we will put the value of lambda, that is 1. So 8 minus 1 is 7. 8 minus 1 is 7. Minus 3 minus 1 is minus 4. 1 minus 1 is 0. And this all as it is. I'll again say please take care of here. You may do some sign mistake. 4 minus 2, 3 minus 4. Okay, yeah. So we have this. Now simply we have to use Cramer's rule. What is Cramer's rule? Basically Cramer's, right here we can let it like x1, x2 and x3. That is equal to 0, 0 and 0. So basically this row will multiply from this column, and this will be this, then this will this, which I have done already. So let me write it. 7x1 minus 8x2 minus 2x3 is equal to 0. Then 4x1 minus 4x2 minus 2x3 is equal to 0. 3x3 minus 4x2 plus 0x3 is equal to 0. So these are Cramer's equations, right? So here we will take any two equations, this or this. So I'm taking these two one. So basically what we do here is that we simply write x1 upon determinant. Remember here which one we are writing. We do not write the coefficient of that particular value. Like I have written here x1, then I will not consider 7 and 4. I'll just consider -8, -4, -2 and -2. So -8, -4, -2 and -2. Now minus x2, here we include minus x2. We do this minus x2, and again we will not take the value of x2, and 7, 4 and -2, -2, -2 is equal sign, and x3 we will not take -2, -2, we will take 7, 4, -8, -4. Okay, so now we have to just calculate it simply. So x1 upon minus plus 16 minus 8, this will be 8 only, and is equal to minus x2 upon 7 2 is 4 minus 14 minus plus 8, so minus 6 is equal to x3 7 4 ja 28 minus 28 minus 32 is minus 28 minus plus 32 is plus 4. So just we have this. Now this is x1, this is x2, and this is x3. So we have written in this form of this. So basically we can write it x1, x2, x3. What will be this? 8 minus 6 or 4. Sorry, not minus 6. This is minus, and then this is minus, so this will cancel. It will be plus 6. Or we can write for lambda is equal to 1, the eigen vectors are 4 3 2. Basically I have just divided by 2 because these all are divisible by 2, so just I have written this. Okay, so there was something how we calculate the eigenvectors for lambda is equal to 1. Now similarly goes with eigenvector for lambda is equal to, we have 3. So again in the same process, like 8 minus lambda, 3 minus lambda, 1 minus lambda. So I'm just writing it. 8 minus lambda means 8 minus 3, that is 5, and minus 8 and minus 2 as it is, and 4 as it is, minus 3 minus 6 minus 2 as it is, 3 minus 4 as it is, 1 minus 3 minus 2. Okay, and now simply we will write here x1, x2, x3, 0 0 0, and again x1 upon, let me write it first. Any two equations, I'm just taking these and these. So 5x1 minus 8x2 minus 2x3 is equal to 0. 4x1 minus 6x2 minus 2x3 is equal to 0. Okay. Now simply the same process, x1 upon minus 8 and minus 6 minus 2 and minus 2. So this will be, I'm just writing the direct value. So x1 upon 4, like minus 8 minus 2 plus 16 and minus 6 minus 2 12 plus 12, so minus plus 12 minus minus plus, then minus 16 minus 12 is 4 is equal to x2. We'll take this minus and we will take 5 4 minus 2 4 2 is a minus 8, 4 into minus 2 minus 8 minus 5 into minus 2 minus 10 minus minus plus, so minus 8 plus 10. Five minus 10, 4 2s are minus 8, minus minus plus 8, to minus 10 plus 8 is minus 2 is equal to x3 upon minus 30 minus minus plus 32 upon 2. Yeah, so here the equations will, here the vector will be 4 minus 2 and 2, or we can write is 2 minus 1 or 1. Okay, so we have, these are the eigenvectors for lambda is equal to 3. And now for lambda is equal to and 2, like so same we will write it. Our equation was this, I'm just actually writing. We have given this 8 minus lambda minus 3 minus lambda 1 minus lambda, 8 minus lambda minus 3 minus lambda 1 minus lambda. So here 8 minus 2 is 6 minus 3 minus 2 minus 5 1 minus 2 minus 1. Okay, and all values as it is, minus 8 minus 2 4 minus 2 3 minus 4, and simply we will write here x1 x2 x3 and we multiply it by this, so plus 6x1 minus 8x2 minus 2x3, 4x1 minus 5x2 minus 2x3. Again the same process, that is x1 upon 8 minus 5 minus 2, so minus plus 16 and minus 10, 6 minus x2 upon 6 4 and minus 2 6 into minus 2 minus 12, 4 into minus 2 minus 8 minus, so minus 12 minus minus 8, so plus 8, so 12 plus minus 12 plus 8 is minus 4 is equal to x3 upon this, so 6 4 minus 8, so minus 30 minus 32 minus plus 32, so 2 minus 30 plus 32, this will be 2. Again here our values are very simple, 6 minus 4 2, so 3 minus 2 1. So these are eigen values. These are eigenvectors for lambda is equal to 2. Okay, so now again we will discuss eigenvalues and eigenvector, but one more thing, that in this previous question we have given the distinct eigenvalues. What will happen will be when we have given same eigenvalues. So this is now we are going to discuss. So again, suppose we have the matrix, we have matrix and need to find eigen values and eigenvector. And we have given matrix A, suppose 2 2 1 1 3 1 1 2 2. We have given this. Firstly, same thing which we will do, that is A minus lambda I. So I'm just doing this directly, I am doing minus lambda. So 2 minus lambda 2 1 as it is, 1 3 minus lambda 1 1 2 2 minus lambda. Okay, now here we have to calculate the values of lambda. So again, I have just told you that we will write this minus h1 lambda square plus h2 lambda minus determinant of A is equal to 0. Okay, so how we will calculate h1? We will add diagonally 2 3 2, so 2 plus 3 plus 2, right? So this will be 7. This is value of s1. Now s2, this will be s2. So h2, this and this, so I'm just calculating directly. So 3 2 is 6 minus 3 is 3, and now this 3, so this and this and this, so 2 1 1 2, so 2 is 4 minus 1 again 3, once again let me calculate 2, this and this will hide. 3 2 is 6 minus 2, here will be 4 3, like 3 2 is 6 minus 2, so 4, and plus according this 2, so this will hide. Then 3 into 2 minus 3, 2 minus 3 is minus 1. So we will add this. 4 plus 3 is 7, minus 1 is 6. This is the value of S2. One second. According to 2, so this 2, according to this we will expand, then 2, this and this will hide, this 2 to 1 3, 32 is 6 minus 2, 6 minus 2 is 4. So 4 plus 4, 8 plus 3, 11. I think same mistake I have done here. This we are expanding according to this. So 8 3 is minus 24 minus 24, so minus 24 and minus 32 minus plus 32, 24 plus 32 minus 24 plus 32, 8. That would be plus 8, right? Yeah, so plus 8. Very simple. It is minus 24 minus 32 minus plus 32, so plus 8. So 14 or 8, 14 and 8 is 22. 22 minus 11 is 11. So here will be 11. Okay, so in this equation we'll put here 11. According to this, if we will calculate, this is what? This is 11. So here now we will solve it, and then now we can easily solve it by calculator. So yeah, again I will just request to all of you, please take care of signs. You may do mistake here. So this is 11. Now what will be determinant of A? So let me calculate here. Determinant of A is equal to like 2. So 3 to the 6 minus, will expand along 2. So 6 minus 2 is 4. Minus 2. 2 minus 1 is 1. 1. Expanding along this. So 6 minus 2 is 4. So 8 minus 2. 8 minus 2 is 6. And plus 4, 10. Four to the 8. Let me expand it again. 2 along this. So 3 2 is 6, minus 2, 4, again minus 2, then this and this and this. So 1 1 and 1 2. 2 minus 1 is 1, and 1 2 minus 3. 2 into 1 2. 1 into 3 minus 3. 2 minus 3 is 1. 2 minus 3 is minus 1. 2 minus 3 is minus 1. So this will be minus 1. So minus 3. So 4 2 is 8, minus 3 is 5. Here will be 5. So again, I will just request you, please take care of calculation. Okay, so minus 5. Yeah, so simply now we will put lambda cube minus s1 is 7, lambda square minus s2 is 11, lambda minus determinant of a is 5 is equal to 0. Again we will calculate the values of lambda 5, 1 and 1. These will be values. Again see this is repeated. That's why I'm saying how we will solve if the values are repeated. Basically here how can we calculate that? Okay, so lambda is equal to 5 1 1. Lambda is equal to 5 1 1. Now simply firstly we will calculate eigen vector for lambda is equal to 5. So we all know that we have given this matrix 2 minus lambda, 3 minus lambda and 2 minus lambda. So 2 minus 5 is minus 3, 3 minus 5 is minus 2, 2 minus 5 is minus 3. And again the all values will be same. So 2 1 1 3 and 1 2. So simply we will write it x1 x2 x3 0 0 0 minus 3x1 plus 2x2 plus x3 is equal to 0. Any two equations. So 1 x2 x1 minus 2x2 plus 3x3 is equal to 0. Okay, and now simply the same process, that is x1 upon, I'm just writing direct values, x1, so this 2 minus 2 1 and 3. So 3 2 is 6, minus minus plus 2 8. Here will be like 8. Minus 6 and minus 6 and minus 2. Here will be minus minus plus 6 and minus 2. Here will be 4 is equal to minus x2, this and this only. So minus 9 and minus minus 9, and for this is, what is this, x1 only, so minus 3. Let me do this, minus 3, 1, 1 and 3, so minus 9 minus 1, oh shit, I have done this here mistake. This is 1, not 3, like we can see in the question. This is 1, okay, this is 1. I have written in place of 1, 3. So basically here will be x3 only. So minus 3 and minus 3 minus 1 is minus 4, x3 upon minus 6, minus plus 6, and minus 2, 4. This cancel, so we can write it x1, x2, x3, 4, 4, 4, or 1, 1, 1. So these are eigen values, eigenvector of, these are eigenvector of lambda is equal to 5. Now for lambda is equal to 1, it goes the same process, that is 2 minus lambda. 2 minus lambda means 2 minus 1, 1, 3 minus 1, 2, 2 minus 1, 1. 2, 1, 1, 1, 1, 2. Sorry. So okay, now just write it, x1, x2 and x3, 0, 0 and 0. So multiply by this and this, so x1 plus 2x2 plus x3 is equal to 0. x1 plus 2x2 plus x3 is equal to 0. And two questions I have written, so I can write here x1 upon 2 and 1, 1. So what will be here, 2 into 1, 2 minus 2, 2 minus 2, 0, minus x2, no, 1, 1, so 1, 0, x3, 2 minus 2, 0, oh my god, here's some glitch, 0 cannot be in denominator. In denominator. So what we will do here is we will change it in this triangle in echelon form. Echelon form. What is echelon form? the triangle matrix becomes 0. We will use some operations like how can we make this 0. So simply R1 minus R2. So basically we are applying the operation in R2, that is R1 minus R2. So 1 2 1, R1 will be as this, and 1 minus 1 is 0. 1 minus 1 is 0. 2 minus 2 is 0. 1 minus 1 is 0. Also in R3 minus R1, 1 minus 1 0. 2 minus 2 0. 1 minus 1 0. And this is x1, x2, x3. Now we have compared. So only this equation, doesn't matter to write this. So x1 plus 2x2 plus x3 is equal to 0. So here let x1 is equal to 2, x2 is equal to s. We have just let it. So t plus s plus x3, so 2s is equal to 0. So x3 is equal to minus 2s plus t, right? So this is x3. This is x3. So basically what we have to do, we have x3 is equal to minus 2s plus 3 plus t, and x1 is equal to t, x2 is equal to s. Isn't it? Is it not? Okay. And now we have to convert it in this form: x1, x2 and x3. x1 is t s and x3 is minus 2s minus t. Or we have to write in form of complete, so I can also write it t plus 0s and s 0t plus s, and here I can easily write like minus 1t minus 2s. And now I can just separate it. I can also write t, 0t and minus 1t plus 0s, 1s minus 2s. We will, if add, then we will get this, and if we will write it properly, then we will get this. I'm just trying to expand it, nothing else. Okay. So now t plus so basically here if I can take t common, then if I take t common, so writing here, if I take s common, so here will be 0, 1 and minus 2. S is common, plus t common, so here will be 1, 0, minus 1. T common. Okay, so I have just taken the common. So now what was t? T was x1. Okay, what was s? S was x2. So basically x1 and x2 is to this. I don't know what I'm doing. So x1, x2 is this, and what was x3? Minus 2 and minus t. So what we will do, minus 2 outside, s is this, 0, 1, minus 2, minus t is this, 1, 0, minus 1. So minus 2 into 0, 0. Minus 2 into 1, minus 2, minus 4, minus 1, 0, plus 1. So ultimately I can also write it minus 1, 0, minus 1, minus 2, minus 0, minus 2 as it is, minus 4, minus 1, minus 5. This is value of x3. Yeah, so this is something how we solve if values are repeated. So now we have another question that again we have to find eigenvalues of 4a inverse plus 3a plus 2i, and A is given matrix of 2 by 2, that is 1, 0, 2, 4. This is the matrix of 2 by 2. Okay, so remember here that we have to find the only eigenvalues, not eigenvectors. Okay, so yeah, again, what is difference between this question and previous questions in these questions? So mainly the difference is that it is in term of, this is new term which we are looking, so simply the same process that we will do a minus lambda I. A is given this, and I, what will be the identity matrix of 2 by 2, that is 1, 0, 0, 1. Means again diagonally we will subtract minus 1. So here will be lambda and here will be lambda. So 1 minus lambda means lambda will be minus from 1, and 0 as it is, and 2 minus 0, 2 as it is, and 4 minus lambda, 4 minus lambda. Okay, so this is our so now here we can simply find the value of lambda. I have already told you that if we have the cubic equation, so we will write lambda cube minus s1 lambda square plus s2 lambda and minus determinant of a. So here we have simply 2 by 2 matrix, then we can write lambda square minus s1 lambda plus determinant of a is equal to 0. So how can we calculate s1? As I have told you already that s1 we simply add diagonally. So s1 is 4 plus 1, that is 5, because we can see the diagonals, in diagonals 4 and 1 are in diagonals, so 4 plus 1 is 5. Simply I can write here 5, And what will be determinant of A? 4 minus 0. 4 into 1 minus 2 into 0, so 4. So here lambda square minus 5 lambda plus 4 is equal to 0, and we can simply solve this equation. So we need to just so lambda, we have to do something like this. If we will multiply, then we should get 4, and if we will add, then we should get 5. So minus 4 lambda minus lambda plus 4. See here if we will add, then we will get minus 5 lambda. If we will multiply both of this, then we will get plus 4 lambda square. Okay, is equal to 0, and we will take lambda common, and then lambda minus 4 minus 1 lambda minus 4. So lambda is equal to 4 and lambda is equal to 1. So here we are getting two values of lambda. Okay, so basically why I did this, let me 1 second. So basically I can here solve by just finding the determinant, because it is a simply square metric, square power, so I can easily solve it. Although if this will be cubic, then we solve in this form. That's why I was solving in this type of form. That's why I have solved it here. So now simply we have this, and now simply we will find eigenvalue for lambda is equal to 4. What we have? 1 minus lambda, 0, 2, and 4 minus lambda. And what can we write? 1 minus lambda means 1 minus 4 minus 3, 0 as it is, 2 as it is, 4 minus 4 is 0. So again I have done here mistake, that I was solving just like previous question, but I will request to all of you that we need to focus here. The see here, we have to find the values of this one, okay, this one. So we need to write this question. It was not needed. So what we have given is 4a inverse plus 3a plus 2i. Okay, so basically a inverse, we can write it, we can replace it by lambda. So 4 lambda inverse plus 3 lambda plus 2i. What does it mean, lambda inverse? Let me just say this here. Lambda inverse means 1 upon lambda. Similarly, like we used to write 2 minus 2 to the power minus 2, then it means 1 upon 2 to the power 2. Okay, so just I can write it here, 4 upon lambda plus 3 lambda plus 2i. And now we are here finding for lambda is equal to 4. So I can easily put the value of lambda, that is 4. So I can put here 4 upon 4 plus 3 into 4 plus 2. And one more thing, that is this is what? This was an identity matrix, and we also know that if we will multiply anything from identity matrix, that value which are we multiplying, that will remain same. I hope that you all know this. So here will be 2 as it is, then 4 to 4 cancel, here will be 1, then 4 3 are 12 plus 1 13 to 15. So for lambda is equal to 4, the eigenvalue is 15. Okay, now we have to also find for lambda is equal to 1. Like we have two values, this is 4 and 1. So simply again we will write the same thing that we have given this equation. 1 minus lambda, 0 to 4 minus lambda, and 1 minus 1, that is 0. I'm just putting the value of lambda, 0, 2 as it is, 4 minus 1, that is 3. Again I have written this here because I have a habit to do this, although it is not necessary. Unfortunately, I am just remembering that concept which I have used in previous questions. So actually in this question we have given this equation, that is 4 inverse plus 3a plus 2i. Okay, we have given this. Simply this can be replaced by lambda. So 4 lambda inverse plus 3 lambda plus 2i. So 4 lambda is equal to 1, we are getting value. So 4 upon lambda, and 4 upon 1, it will be 4. 3 into 1, it will be 3 as it is, plus 2 into identity matrix, that will be same. So 3 to 5, 4, 9. So 9 is the eigenvalue for lambda is equal to 1. So I hope that you have understood this question very properly. Like what we have to do, find the eigenvalue for this equation and this Bose matrix 2 by 2 which we have given. Simply first process, we all know that we have to calculate the value of lambda. Firstly we have done this, then we have calculated the value, and there was lambda square minus 5 lambda plus 4, this is the equation, and we have just solved it. And then this part was not necessary. I did this by my mistake, and then we have given this equation. We have changed in place of a we have put it lambda. So this is the equation. Then we have put it for lambda is equal to 4. Then we got this lambda for eigenvalue lambda is equal to 4, it is 15, and for lambda is equal to 1, it is 9. Okay, so now let's move on to the next question. That this was 3 by 3 matrix. Now suppose we may have 4 by 4 matrix. Again we have to find eigenvalues. We have to find eigenvalues of a cube plus 5a plus 8i. Now here matrix is given, that 3 by 3 order, that is -1 2 3 0 3 5 0 0 -2. Again this is the 3 by 3 matrix. We will do the same process, that firstly we will find the value of lambda, and then after we will replace it by lambda, and then we will put the value of lambda and we will get the answer. Simply, so the most important things which you should notice, that here this is 0, we call it a diagonal matrix. Here this is 0, so I can directly write the value of lambda. So basically I can write if the triangular part of matrix here, what is this? This is A21, this is A31, A32. If this is 0, is 0, 0. So we can directly write the value of lambda. Okay, and what will be the value of lambda? These diagonals will be value of lambda. There is lambda 1, lambda 2 and lambda 3. So from this statement I can write the value of lambda. Lambda 1 is equal to -1, lambda 2 is equal to 3, lambda 3 is equal to -2. Oh, sorry, I did a mistake here. So not lambda 1, lambda 2, lambda 3. So lambda have three values, that is -1, 3 and -2. Lambda have three values. Okay, so let me drink the water, then after we will discuss. Okay, so now we have the values of lambda. So the same process that we will do, a minus lambda I means a is given this, and lambda I, here what will be the I, like here is identity matrix which is 3 by 3 order. So what will be like 1 0 0 0 1 0 0 0 1. So means lambda will be diagonally, then after we will minus from a. So a minus means -1 minus lambda, 3 minus lambda, -2 minus lambda, and 2 3 as it is 0 5 0 0. Okay, so we have this, and now we have to solve, and we need to just now we will do, now we will put the value of lambda. So just we have this. Again I have done the same mistake, that we do not need to do this because we have given this, this is given. So we have given, so it's called the habit. Now just I was solving from this type. I have solved almost 10 to 15 questions, so I have built a habit to solving by this method. Although we have given, I always forget this. So there was given a cube plus 5a plus 8i. We can replace it by lambda. So lambda cube plus 5 lambda plus 8i. Now here we are finding for lambda is equal to, that we have the three values, so lambda for lambda is equal to -1. Okay, so -1 cube plus 5 into -1, and identity matrix, if we will multiply by anything then it will be as it is. So -1 as it is, see there is 1 -1, so -5 plus 8. Okay, so what will be here? Here will be only 2. So 2 is the value, 2 is the value, 2 is the value for is the eigenvalue for lambda is equal to -1. Okay, now same goes with lambda is equal to, now second value is this, 3. Simply now I'm doing just directly putting the value 3 in place of this. We have given 5 lambda plus 8i, so we will put 3 cube plus 5 into 3 plus 8, so this will be as it is. So 3 into 3 into 3, that is 27 plus 15 plus 8. So 27 plus 15 plus 8. 27 plus 8 is 35, 5, 40 and 50. So 50. Eigenvalue. 50 is the eigenvalue for lambda is equal to 3. Now for, sorry, it was not visible. Now for lambda is equal to minus 2. For lambda is equal to minus 2. Just as it is, nothing need to do. We have given this lambda cube plus 5 lambda plus 8i. So just we have to put the value minus 2 cube plus 5 into minus 2 plus 8 minus 8 minus 10 plus 8 minus 18 plus 8, that is plus minus 10. So it is the eigenvalue for lambda is equal to minus 2. Okay, so I hope that I am successful to understand you that how to do these type of questions. Firstly, I take the matrix of 2 by 2, then I take the matrix of 3 by 3. Simply here it was easy to find the value of lambda, so just I have find the value of lambda. We all know the process that how to find the value of lambda. I have just find the value. It was not necessary to write. I have told you that I have written this by my mistake because I was continuously forgetting this equation, that if we have given this, then it is not necessary to write this. Simply we have given this, we need to replace it by lambda, and simply we have the values of lambda and lambda, so we need to just put the value, then we will get the answer. So what are the total eigenvalues for this? So first eigenvalue is 2, then is 3, so then is 50, then is minus 10. So these are eigenvalues for this. Now we will see a Cayley-Hamilton theorem. We will see a Cayley-Hamilton theorem. Sorry, I think I will write the so date. I forgot to write the date. So date is 16th of February 2025, and this side is Raghvendra Singh. It's necessary, no? I will be able to remember that when I discuss about this chapter. So, Cayley-Hamilton theorem. We all know that Cayley-Hamilton is the name of mathematician who is the great mathematician. He gives the statement what he said, that given equation should satisfy their own matrix. Means if any question will be given, then it should satisfy their own matrix A. Suppose we have given any A matrix. Well, let me write the first definition. He said that given equation should satisfy their own matrix A. Now we will do a question and simply we will get that how it actually helps us to solve complicated problems. So simply let's take an example. We have to verify Cayley-Hamilton theorem. I will write it in short CHT. For the matrix A. Hence we need to find A inverse A to the power minus 2 and A to the power 4. We have to find this, and the matrix is 3 by 3 matrix, that is 1 2 minus 2 minus 1 3 0 0 minus 2 1. So this is matrix which we have given. Okay, so first of all we will do the same process, that we will simply apply this A minus lambda I to find the eigen values. So I'm just doing diagonally minus lambda, so we can write it like this: 1 minus lambda, 3 minus lambda, 1 minus lambda. Okay, now simply we have to find the value of lambda. So what we used to do is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equal to 0. So in bracket, what is process to solve S1? How can we find S1? We simply add diagonally. So 3, so 1 plus 3 plus 1 is equal to 5. And what is process to solve S2? It is also very simple. We find the minors of diagonals. So we have 1. We will hide this, so this will be the 3 0 minus 2 1. 3 0 minus 2 1. So 3 minus 0, it will be 3 as it is, plus 3 minus of 3, then this we will hide, then this. So 1 minus 2 0 1. So this will be 1 as it is, plus now 1. So this will hide this. I'm just calculating the minor. So 1 2 1 3. So 3 minus 2, 3 minus minus 2, 3 plus 2, that is 5. So this will be 9. Okay, the value of S2 is 9. Then now one more thing that we have to calculate also. value of determinant of A. So value of determinant of A, if we will do according to expand according to A, so I should solve or write it directly. Let me just solve. So value determinant of A, you all know that how to solve the value of A, determinant of A, that 1 in bracket 3 minus 0 3 stage, then minus 2 this and this, so minus 1 0 0 1, it will be 0, right? No, minus 1 0 0 1, so minus 1 minus 0, it will be minus 1, right? Minus 1 and minus 2 along this, so minus 2, what will be this, minus 2, so this and this, so 1 2 minus 1 3 3 minus 2, 3 plus 2, that is 5, so it will be total 3 plus 2 minus 10. And it is coming minus 5. I have done some mistake, let me check it again. So basically we have to expand along 1, so 3 0 minus 2, so 3 will be as it is, 3 minus 2, this and this will be hidden, then minus 1 0 0 1, so this will be minus 1 only, minus 1 as it is, and this will be minus, here's minus 2, yeah, it is minus 2, so minus 2, this, sorry, minus 2, this and this, so minus 1 3 0 minus 2, so minus plus 2 minus 0 plus 2 minus 0 plus 2 minus 0, so it will be 2 only, so here will be 4 only, here it will be 4. Okay, so remember here you can do some calculation mistakes, so here will be 4 only, so 3 plus 2 5 minus 4, that is 1, so determinant of A is equal to 1. Now simply put all values here, lambda cube as it is minus s1 value is, s1 is 9 lambda square plus s2 is sorry, this is 5, s1 is 5, s2 is 9 minus 1, determinant of A is 1, is equal to 0. Now simply we can solve it. Simply we can solve it by taking lambda common, then here will be lambda square minus 5 lambda plus 9. And we can solve it. I am not solving the equation, just I am writing the values of here. Again, we do not need to find the value of lambda, simply that here we apply, hence applied Cayley-Hamilton theorem. What he said that given equation should satisfy their own matrix. So this is the equation. So what is matrix A? It means A cube minus 5A square plus 9A minus 1 is equal to 0. So it should satisfy it. Got it? It should satisfy it. Then we can say it is, hence Cayley-Hamilton theorem proves. So now here it is very lengthy, that we will calculate A cube, then 5A square and then 9a, then minus 1. So basically, how we'll calculate a? We have this a, and again a into a, then into a, then something. How we will get a cube? We all know. Let me solve it in rough. Where is rough copy? Okay. Let me solve it here. Okay, so this is we have a this. We are doing a into a square, right? So we have a 1 2 minus 2 minus 1 3 0 0 minus 2 1 into again 1 2 minus 2 minus 1 3 0 0 minus 2 1. So we all know the process of doing multiplication, that this is row, this will multiply from this, then this, and then this, something like this. 1 into 1, 2 minus 2 into minus 1, minus 2, minus 2 into 0, 0, 0. Here is the sign of plus, not into, and then second, this to this, 1 into 2, 2, 2 into 3, 6, minus 2 into minus 2 plus 4, minus 2, 0, minus 2. So similarly goes with this, then we will get a square, then again we will multiply it with this a again, then we will get a cube, then same we will put the value of a square, then a is given, then we will solve it. So I have just already calculated it, and I have also told you that how to calculate a cube. So I'm just putting the value directly here. So basically what will be a cube? It will be minus 13, 42, and minus 2, minus 11, 9, and 10. 10 minus 22, 3, minus, just see, here is 5 in coefficient, so 5 will be outside. 5 will be outside. Then we will put the value of a square, which I have calculated. There's something like this, like here will be minus 1 and 6 to 8 and 12, so minus 1, 12, and this will be minus 4. So here is 2 plus 2, 0, so this will be minus 4, minus 2, minus 4, minus 4. तो जगह की कमी पड़ रही है. Okay, this is minus 4, and same goes with and minus 4, 7, 2, and 2 minus 8, 1. Okay, so we have this, and now here's 9a also. So I'm just doing this here, plus 9. Sorry, a is this, we will put it as this. So 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1, and all over equation here is again minus 1 is equal to 0, and we have to solve this. Should I solve in next page or here? So and this will be good to solve it here, because I will face some difficulty to solving in next page. So basically we will write it as it is: minus 13, 42, minus 2, minus 11, 9, 10, 10, minus 22, 3, and minus 5. If we will multiply this, then it will multiply all over. Okay, so minus 5, 60, 4 into minus 5, so it 4 into minus 4 into 5, it is minus 20, and minus 20 again, and 35, 10, 10, minus 40, 5. Okay, so we have done this here. So first we solve it or complete it. It will be very lengthy, so I'm just doing it. Plus 9 will go inside, then 9, 18, minus 18, minus 9, 27, 0,